Mostly we're going to be using formulas, but in the more advanced statistics courses, you'll be proving formulas. So we'll do a little bit with proofs here, not a lot with proofs, but here this theorem here says that when exam scores are weighted equally, with weights adding to 1, the weighted mean is always the same as the original mean. Okay, so in symbols, we want to show that the summation as I goes from 1 to n, xi wi, is the same as summation I equal 1 to n of xi all over n. I could have used I or k. I happen to use I here, but the index, I is what's called the index, and it doesn't matter if we have an I or a k there. Okay, so usually when you do a proof, you start with the left side and try to manipulate it until you get to the right side that comes out to be the right side. So the summation as I goes from 1 to n, xi wi, that's equal to the summation I goes from 1 to n of xi times 1 over n. And that's because we're assuming the scores are weighted equally. So if we have n exam scores and they're weighted equally, then each weight is going to be 1 over n. Just like if you have a pizza and you divide it among 3 people, then each person gets 1 over 3, right? Or if you have a pizza and divide it among 17 people, each person gets 1 over 17, or 1/17 of a pizza. In this case, we're weighting exam scores equally. There's n of them, so each weight is going to be 1 over n. So then we can use the definition of sum. What does sum mean? It means the first exam times its weight, plus the second exam times its weight, plus etc., plus the last exam times its weight. That's by definition of sum. The 3 dots mean etc. And then we can use the distributive property. We have a common factor of 1 over n. We can factor that out outside parentheses. So inside parentheses, we have x1 plus x2 plus etc. plus xn. And then outside parentheses, the whole thing is times 1 over n. And then we can go back to sigma notation again. So x1 plus x2 plus etc. plus xn. In sigma notation, that's the sum as I goes from 1 to n of xi. And then just copy the 1 over n here. And then we can use the rules for multiplying fractions. And put the part that's not a fraction, put that over 1, multiply straight across, and we get the summation equal to the summation I equals 1 to n of xi all over n. And that completes the proof. And that completes this presentation.